Welcome to 7th grade math. Hello class. Today we talked about how we can use the Pythagorean theorem to find the unknown lengths of a right triangle. So basically, Pythagorean theorem states that THM is the abbreviation of theorem. So you have a right triangle and let's label the legs A and the other leg B, and the side that is opposite side, on the opposite side from the right triangle, where the other two angles are just very acute angles, right? So that right angle, the side that is opposite, sitting right across from the right angle, we call that hypotenuse. And that's the longest side out of all three sides of a right triangle, okay? So the longest side of a right triangle, which is located right across from the right angle, that always has the longest length, okay, compared to the other two. So anyways, Pythagorean theorem states that if you square each leg, so for example, you square, I'm going to start with A. You can always start with the other side B. That doesn't matter. The order doesn't matter when it comes to addition. You square each side, which is A squared, and then you square the other side, which is B squared. The sum of the perfect squares of those two legs, the sum, you mean if you combine them all, if you combine both, that's always equal to perfect square of the third side, which is the hypotenuse. That's what the theorem states, okay? So yes, Pythagorean theorem is used to find the unknown lengths of a right triangle and right triangles only. So knowing that, we can try a couple of problems, and let me come up with, sorry, I'm trying to help Summer get dressed for the bedtime. Example 1. Okay, example 1 is, you have a right triangle, okay? You have a right triangle, and this right triangle has leg that is 6 miles, and hypotenuse that is 10 miles. Should we draw up this right triangle? All right, so you have a right triangle. I'm gonna draw it. Ooh, I want to make my sides all, no. So straight lines right here. And then right there. Okay, so let me mark that angle, right angle. Okay, so this right triangle has a leg 6 miles. So can I label this leg? It doesn't matter which one you label 6 miles, but hypotenuse is 10 miles. And again, hypotenuse is the side that is sitting right across from that right angle, which is the largest angle out of all three, right? Because the other two have to be acute. So it's open that much, so it's got the longest side. Whereas the other angles are open just this much, and just this much. Of course, the opposite view is not as long as the view from the right angle. That's how you know. It just makes sense. Very, very logical. All right, so that's what we have. Can you find the length of the other leg, the unknown length of the, so let's call that x. That is the unknown length of the second leg. All right, so let's bring in Pythagorean theorem, a squared plus b squared is equal to c squared. I can plug in 6 here or even there. The legs, the order doesn't matter, okay? But what matters is hypotenuse. So no matter what, C is the position for hypotenuse. So 10 is the value of C, okay? And then I can just plug in x squared plus 6 squared, or I can even do 6 squared plus x squared is equal to 10 squared, right? They're the same, pretty much the same equation, because we're saying 2 plus 3 is equal to 3 plus 2. Same thing. All right, so let's work with the first equation and save us some space. All right, this is an equation. Let's simplify it. X squared plus 36 is equal to 10 squared is 100. Now, remember, this is an equation. It's a quadratic equation, okay? It's an exponential equation. What is our goal when you solve an equation? Our goal is always to isolate the variable to find the value for x, okay? Same when you solve a radical equation, when you solve a rational equation, when you solve a linear equation, quadratic equation, exponential equation. Goal is always the same. It is to isolate x and find the value of x. Now, x is with the other term right here, plus 36. Therefore, we're going to have to undo that guy, right? How do you undo plus? You need to minus them, don't you? And you do it to each side of the equation. That way, these two terms will cancel each other out. That's the inverse operation. And therefore, x squared remains the same. Equal sign remains the same. You just have to do this out, which is 64. And you think something squared is equal to 64. Okay, you're thinking something squared meaning something multiplied by itself. That's what it means to square, right? That's equal to 64. Then what should something be? X is equal to 8. Does that make sense? Well, I gave you a unit, which was miles, so answer is 8 miles. So I'm going to bring this back to the diagram. Let me see. X is equal to 8, oh, not centimeters, 8 miles. Does that make sense? Sure. That looks pretty reasonable, right, guys? You see that? As long as this length right here, 8 miles, is shorter than the hypotenuse of the right triangle, that's good enough, right? Okay, for now. Wonderful. So that's how you use the Pythagorean theorem to find the unknown length. Now, I would like to do one word problem, and let me grab a problem from your textbook, okay? So, here we go. Ready? Let's all look at page 404 and number 33. Okay, 404, number 33. A ladder leans against the side of a building. So here's your building. Okay, how many stories is that? Let's make it 1, 2, 3, 4, 5 story. And interestingly enough, this high-rise building has a chimney. All right, so ladder leans against that side of a building. Where's my ladder? Right here. Here's my ladder. Ta-da. Whoa, nope. So here's my ladder. Ta-da. Wow, you guys, such irregular. Okay, so here we go. Reaching a height of 12 feet. It says we're doing trying number 33 on page 404. A ladder leans against the side of a building, which as I drew, reaching a height of 12 feet. What does that mean? This height right there, that is 12 feet. Okay? If the ladder is 13 foot long, what does that mean? This side right here is 13 feet. That's what it means. Determine the distance from the base of the ladder. Where is the base of the ladder? It's right here. To the building. This is what you have to find. Does that make sense? Okay. So once again, let's run it again. Okay. We're still mapping. Ladder leans. That ladder, it leans against the side of a building. This is the side of the building. And it's reaching a height of 12 feet right there, okay? And ladder itself is 13 feet. That's what the problem says. So ladder itself is 13 feet. And the problem is asking you to find the distance from the ladder to the building. So there is your right triangle. Let me take it out of the picture so it's less confusing for you. All right, so here's my right triangle. And here is the longest side of a triangle called the hypotenuse. Here's my right angle. Right there is 12 feet. The hypotenuse of the right triangle, which always, I can't say enough, it's sitting right across from the right angle, right? And we're looking for the base, the length of the base. All right, you guys, what did we say? Pythagorean theorem is x squared plus b squared is equal to c squared. The most important thing that you have to remember is that c is always the hypotenuse of the right triangle. Where is the hypotenuse? Is the length given? Yes, it is, right here. So you just plug that in here. So that will look a squared plus b squared is equal to 13 squared, isn't it? Now, are you given any of the legs? Yes, you are. You're given one leg length, 12. Mrs. Moon, where can I plug in? Is it for A or B? It doesn't matter. Either leg, okay? So I'll just, for the convenience of it, 12 for A, for the first unknown variable. So plus B squared is equal to 13 squared. In your head, I know you guys can, it's like on the top of your head, 169, right? And 12 squared, it's 144. So plus b squared is equal to 169. Now you're solving this equation. Again, when you're solving an equation, ultimate goal is to isolate the variable. Find the value of a variable that satisfies the equation we plugged in. Now, b squared has this plus 144 next to it on the same side. You got to undo all of those. So b squared is all alone, and then afterwards we're going to have to undo, right? Perform the inverse operation of the square. All right, so therefore you subtract 144 from each side of the equation. That'll take care of these guys, right? And I bring down b squared, I bring down equal sign, and you do this operation. 169 minus 144 is 25. Now, it all of a sudden, a lot of things like kind of cleared out, right? Now, b squared is equal to 25. Again, squared means you're multiplying b by itself twice. Exponent represents how many times you multiply the base by itself, okay? Equals 25. What number do you multiply by itself twice to get 25? Isn't it 5? So b alone is 5. And did I give you the unit? Oh, yeah, feet. That's what I found. And you plug it back into, okay, so implement it right here, okay? So x is equal to 5. So 5 feet. Does that make sense? Take a look at it. Yeah, definitely. Sure. 5 feet. 5 is shorter than 13 feet, okay? A leg should be shorter than its hypotenuse, of the triangle. So yes, makes sense. Yeah, so that is how you use the Pythagorean theorem to find the unknown lengths of a right triangle. All right, that was it. Okay, good job, class. See you tomorrow. Bye.